Everything we have covered so far, snapshots, time travel, rollback, branches, tags, none of it is abstract. These are patterns real data teams hit every week. Let me now walk you through 6 situations where this changes how you work, all against our orders table. First, compliance. A regulator asks what customer 101's order looked like before it was marked as shipped. Let's run this and wait for results. One row, the laptop status pending. That is the exact state of that record before the update ran. No log files, no audit database, no reconstruction. The table already knows what it looked like at that moment. You just ask. Second, ML reproducibility. A data scientist trains a model today and wants to retrain on exactly the same data 6 months from now. Let's run this and wait for results. Now the training set is bookmarked. 6 months later, regardless of how many writes have happened, let's run this and wait for results again. Same data, frozen, reproducible. The tag is a permanent named pointer that survives expiration for a full year. Third, debugging ETL. You want to see exactly what a pipeline changed. First, capture the current snapshot before running anything. Now simulate a job running. Now let's find what changed. Orders 1 and 2 exactly what the pipeline removed. Now let me restore the table before we continue. Fourth, disaster recovery. Bad data was written 30 minutes ago. Let's run this and wait for results. 5 rows. Done. No backup restore, no pipeline replay, no on-call engineer needed at 2 a.m. Fifth, A/B testing. You want to run experimental logic without touching production. Let's run this and wait for results. Now let's write only to the branch. Now let's check the branch. And finally, let's check the main. Production has no idea the experiment is running. When the team decides promote the branch or drop it, either way, main is untouched. Let me drop the branch now to keep things clean. Sixth, GDPR right to be forgotten. This one is more nuanced than it looks, and I'm not going to run these live because they permanently alter storage. But let me show you what the full purge looks like. This query removes the record from the live table. This part expires all snapshots that still reference the old data. And finally, this part rewrites data files to physically remove deleted records from disk. 3 steps: delete the row, expire the snapshots that still hold it, and rewrite the physical files on disk. After all 3, the record does not exist anywhere, not in the live table, not in the history, not on S3. Most of the platforms cannot do this cleanly because they do not give you access to the storage layer. IOMETE does this because the data lives in your infrastructure and you control every layer of it. 6 use cases, same underlying mechanism for all of them. That is snapshots, compliance, reproducibility, debugging, recovery, experimentation, deletion. The architecture does not change, only the query changes. Now, 10 best practices. These are the things worth keeping close when you start using Iceberg in production. First, always use format version 2 Version 1 does not support row-level deletes, branches, or tags. There is no reason to use version 1 for new tables. Second, tag before risky operations. Migrations, schema changes, big merges, model retrains. A tag costs nothing and gives you an instant exit if something goes wrong. Third, set retention policies explicitly. Do not let snapshots accumulate without bounds. Set retain periods on your tags and define expiry schedules from day 1. Fourth, run expire snapshots on a schedule. Daily or weekly depending on write volume, pair it with remove often files to clean up storage completely. Fifth, use branches for experimental writes. Never run test ETL on main. Create a branch, run the experiment, promote or drop. Sixth, document your tag naming convention, something like Model v3 training or pre-migration. Consistent names make the refs table readable at a glance 6 months from now. 7th, tag, train, archive for ML. Tag the training data, train the model, keep the tag alive for as long as the model is in production. 8th, do not use time travel for hot query paths. Time travel adds metadata reads. For frequent high volume analytical queries, always use the current snapshot. 9th, schedule maintenance off hours. Rewrite data files is compute heavy. Run it when cluster load is low. 10th, watch metadata file size. If your metadata JSON grows past tens of megabytes, you are not expiring snapshots aggressively enough. Now here is the takeaway. On IOMETE, time travel is not a backup product you bolt on after something breaks. It is the way every Iceberg table works by default. You do not need to change how you build pipelines. You do not need a new tool. You just need to understand what is already happening every time you write to a table. So that's it for this video. Thank you.